How about partial roots? This is not too complicated. You should keep in mind the important square roots like 9, like 27, and so on, right? And some square root of 16, that's and so on. You should keep in mind the most important ones, and then you also can look for those numbers, right, when you have them in your mind. Or like 64, there are a lot more numbers you can look out, like 3 times 3 times 3 is 27, so you can say 3 times 3 is 9, 3 times 9, and then you can take the square root of 9, 9 gets out of the square root, then you have 3 times the square root of 3, like this. And this is something not too difficult, but of course it should be in a tool set of math students to be able to do this. So I'm going to show you how it works in the following, and no problem, it's very easy. How about calculating partial roots? Actually not too difficult, but you need to have a little bit of training, and then it's quite easy. So the way it works, given you have some root, and now we want to extract a root, but the thing is always sometimes, for example, if you have the square root of 10, then the outcome is not a nice number, and this is where you use partial roots. So in this case, you might be able to say the square root of a is something like b times c, and then you can say maybe square root of b times square root of c, and then the purpose is that one of those square roots then finally is a natural number, so that it looks nicer. This is actually already the purpose why to do partial roots, just to make it look a little bit nicer, because otherwise you could always calculate it straight away. You could use the calculator, and then whatever it is, you can calculate it, although it might not be a nice number at the end. But this is why to do partial roots. So I just show you a few examples. Then we start with square root of 1000. And then if you would use the hammer, you just use a calculator, you just say square root of 1000 is something like this, and you just write it out. But this is not about partial roots. Partial roots makes it look a little bit nicer, but we need to think a little bit. And then we say 1000 is, in this case, okay, I already know the solution and I already have a little bit of training. I would say, because it's 100, it's 100 times 10. And then I can also write differently, square root of 100 times square root of 10. And I know from experience, because I already calculated a million times in my life, square root of 100 is 10. And this is a natural number. This looks quite nice. So the outcome then will be 10 times square root of 10. And one thing for this kind of exercises we omit that it actually should be plus and minus. Why is that? Because 10 times 10 is 100, but also minus 10 times minus 10 is also 100. This is just to keep in mind, but in this exercise we will omit it. So let's calculate another example, square root of 50. Then you might already see it. This is just, I would say it's just a matter of training, to train your eyes so that you can see it immediately. I think most of topics in mathematics are like this. You have to train your eyes towards specific tricks, and then you can apply it very easily and very quickly. So 50, I know already 25 times 2, and I know 25, the square root of 25 is 5. And I can also write it like this, 25 times, square root of 25 times square root of 2. Then I know from experience it is 5. You can also, but I think it's just a matter of practice to extract a number before you really extract the root. So, third example, 250, and you also already see 255, there's some 5 involved. Also you see 25, and then we just say 25 times 10, so I already separated it and the square root of 25 is 5, so I have 5 times the square root of 10. So actually it's not too difficult, but of course, as with everything, practice makes perfect, and the more you calculate with these, the easier it gets. And so in the exam, it will only be a small problem just to calculate a partial root to make it look nice, or if the exercise is given like this, that you can also calculate back to something like this, so that you can just play with numbers and that you know what you're doing. So this is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheeps.com.